Veyron's massive disc brakes aren't enough to handle the car's incredible power, Bugatti engineers face yet another challenge. Stopping a car that's traveling at nearly 1/3 the speed of sound. The Bugatti Veyron can stop faster than any production car in the world. That's because the Veyron actually has two different braking systems built into the car.
We have the mechanical brakes to the wheels, but we have also an air brake.
At speeds above 125 miles an hour, hit the brake pedal and the Veyron's rear wing shoots up to a 55-degree angle.
It is very helpful when the car is very fast.
The wing acts like an air brake, providing almost 1/3 of the Veyron's total braking power. The air brake alone generates 70% of the braking power of a normal car. Together, the wing and the disc brakes have a total braking force equal to almost twice the force of gravity. The Veyron takes less than 10 seconds to go from its top speed of 253 miles an hour to a complete stop. No other car made has brakes that can do that, or even come close.
You can brake faster than you can accelerate.
2.5 seconds, it needs to accelerate to 100k, and in 2.2 seconds it already has stopped down to 0, which is a very impressive number, I think. It's amazing. Below 5 seconds, the whole thing.
Even more amazing is how the power of the brakes dwarf the power of the Veyron's huge engine.
Deceleration takes about 4,000 horsepower to brake the car from top speed down to 0.
In its up position, the Veyron's rear wing helps braking. Lowered, it adds stability to high-speed runs. The rear wing is a critical part of the Bugatti Veyron. But to control the wing means creating something so fast, its speed is almost unimaginable. Speed measured in picoseconds, 1,000 billionth of a second. MTS Sensors is a high-tech company in Ludenscheid, Germany, about 100 miles northwest of Frankfurt. It's here where they build a remarkably tiny sensor unit for the Veyron's rear wing.
It is the fastest piece in that car.
The sensor measures the time it takes a pulse of light to travel down a wire, hit a magnet, and reflect back as an ultrasonic sound wave.
The sensor performance has to be not only correct, but also has to be quick enough that the computer system in the car can execute the right angles on the wing as needed.
For normal driving, the wing is retracted. Hit 136 miles an hour, and the wing pops up to a 15-degree angle. For high-speed runs above 230 miles an hour, the wing retracts to just 2 degrees. And for high-speed stops, the wing hits 55 degrees in 0.4 of a second. The Veyron adjusts its aerodynamic configurations on the fly. Without the tiny sensor in the wing, the car would never be stable enough at 253 miles an hour. And it would be even worse if it did go that fast. Without the tiny sensor in the rear wing, the car could never safely brake from that speed.
Without the sensor controlling the wing and the computer knowing the information on the wing and varying the angles on the wing, they would not have been able to do that.
Each sensor is handmade. A wire half the thickness of a sewing needle, light and sound waves. A tiny magnet is welded to the wire under a microscope. Everything about the sensor is remarkably small.
The weld is 1/10,000th of an inch. It's a very small weld.
The sensor is tested, sealed inside a weatherproof housing, tested again, and then packaged for shipment to Hegemon Aerospace. A company that specializes in making parts for jets and rockets. They install the sensor in the strut assembly for the Veyron's rear wing. Then, it's checked on a machine made just for the Veyron to make certain both sensor and wing work perfectly.
The rear wing is a good sample for the combination of automotive and aerospace, because this hydraulic system could also drive a flap system in an aircraft wing.